probability 没有学过这个，没有学过。就是你随便丢那个棍在那个线上面，然后会有拍一个棍停在那个线上面。没有学过 probability，没有学过，是真的。然后学过在 probability。哎呀啊，看到学过，是你量多少个那个棍点在那个线上面？不学到，有2个。对咯，所以你跑去学那个 a n s 比较大一点，所以你跑去学那个 a n s 比较大。只是点8，很好。OK，完了，左手。多一个联络，那哎这边那个，那我手里我推出去好，那我不用做历史，做2.6，所以他就这样，他就是那个水电给拉，然后找那个来去掉。只是他题目问到很乱啊，各种各样。啊，哦，那个他那个对啊，X Y 点。try to 把我那个东西为点对吗？还有，
你看，大家又来，
太那个
太累了。
又来，也不是讲有一下吧，
看一下吧。
是
喂，看第三个，
我自己
第一个，
啊？为什么？
因为是他受人吃了。还有什么聊起啦，细微感到，证明你聊失败呀，我嘛，
也传这样 form 吗？
爸爸，
给我不想不想。哎，传统魅力是特别好，是现实没有我。
Testing. Okay, good morning. Very good morning. Maybe we should start first. Okay, did anyone go back manage to compute this example last time? Wanna try this yet? Huh? You want to try? No one. Okay. Let's discuss. What should we do for this question? Okay. So evaluate the double integral x y dA, where D is a region bounded by the line y equals to x minus 1 and the parabola y squared equals to 2x plus 6. Okay, so this graph is in R3 or R4? Huh? R2? I only have two choices of R3 or R4. Huh? This XY graph, I'm referring to this XY. This graph is in R3 or R4? R3, right? Okay. Because the domain is R2, okay, the range is R. So altogether you got R3. So what's this picture here? Okay. So this picture here is the domain. Okay. So you should know how to plot this simple graph. Okay. Simple graph. So you should know how to plot y equals to x, and then x squared equals to 2x. Okay, simple graph you should be able to plot y equal to x and y squared equals to 2x. Okay. So y squared equal to 2x, right? Is going to the left or to the right? Facing left or facing right? Y squared equals to 2x. Should be facing left or facing right? Huh? Right. Why? Square root is always positive, and then also this 2x here is positive. Okay. If x is negative, you won't solve this equation. Okay. Make sense or not? Make sense, huh? If x is minus 3, for example, then you won't solve this equation. You won't find a y. Okay, so this means this has to be positive. So face right. Okay. Yeah. Okay. So if you add some random number, you just shifting the graph. Okay, you just shifting the graph. Okay. So y equals to x minus 1 is y equals to s shifted down by 1. Okay. And then y squared equals to 2x plus 6 is y squared equals to 2x shifted up by 6. Okay. So do you know how to find this intersection line or not? Intersection point or not? You just sub them into each other. Sub the equation into each other. Okay. And then find the intersection point. Okay. So how many ways to compute the double integral if the function is continuous? Huh? How many ways? Fubini's theorem. Huh? Two ways. Okay, iterated integral. dy dx or dx dy. Okay, so two ways you can compute. They both compute to the same number. dy dx or dx dy. Okay, so there are two pictures here. Okay, they draw the cross section area for you. Okay, cross section for you. So one is vertical, one is horizontal. Okay, can you decide which one is dy dx, which one is dx dy? Which one is dx dy, which one is dy dx? The right one is what? This is dy dx, and then the other one is dx dy. Okay, so why? Okay, so the variable that you integrate last is the one that you fix first. Huh? Yeah. Wait, let me explain, then we will see something wrong. All right. Okay. So the variable that we integrate last is the one that we fix first. Okay. For example, if we put dy at the last, so we fix dy direction first. Where's y? Y direction is this. Okay, we fix y. Okay, not y direction, but we fix the y interval. Okay, and then we integrate over x first. Okay, x is this direction. Okay, so this matches up with this picture here. Okay. Okay. So again, so for example, dx dy, okay, the outer variable get fixed first. Okay, so we fix the range of x first. Okay, and then we integrate over y direction. So it's this over y direction. Okay. After we integrate, so we go another way. So if we integrate the y direction first, and then we combine all the x direction, you also can think like this. Okay, you can think from outside to inside and inside to outside. Okay, depend on whatever you want to think about this iterated integral. Okay, so I repeat again. For example, this dx dy. So you integrate the inner part first, and then you integrate the outer part, right? Okay. So if you integrate over dx, what does it mean? So you integrate the x direction first. Okay, x direction. And then after you integrate every line, right, you need to add out every line. So you integrate over y direction. Yeah. Make sense or not? Okay. Okay. So makes sense. So try which one? Okay, so try this one first. Okay. dx dy. Okay, let's say I want to integrate with respect to dx dy. What's the range of x and what's the range of y? Let's say we already compute all the intersection. Where's the range of x? You need to fix the range of okay, fix range of y first. So what's the range of y? -2 to 4. Okay. How about x? -3 to what? -3 to 5. Okay. What's this picture here? What's this picture? What's this picture here? Huh? Rectangle. This is a rectangle from -3 to 5, and then y from -2 to 4. This is a rectangle. Okay, but you don't want rectangle here. Okay, so how to get this with this shape here, this bounded shape? Huh? Change the domain of x. How to change? How to change the domain of x? What's this rectangle? This rectangle actually is the rectangle that cover the whole domain. Okay, but we don't want there's something extra here, right? Okay, so how to find x? How to find x? Yeah, from left to right. So left is bounded by what? Right is bounded by what? Half y squared -3, and the other side y plus 1. Okay, so the left side is controlled by this curve, the right side is controlled by the other curve. Make sense or not? Okay. Okay. So in this case here, this integral is integrating from -2 to 4 and integrate from half y squared minus 3 to y plus 1 of our function xy dx dy. Okay. So do you know how to do this iterated integral? So you solve the inner integral by using partial integration. So you integrate with respect to x, treat y as constant. Okay. And then you can see that you will sub everything in terms of y and then you integrate with respect to y plus. Okay. Okay. How about okay, I let you try. Let's compute all of you compute this integral. I give you three minutes. Then compute this integral. And then check you get the answer. To this integral here. Okay. Do you manage to get something? Huh? Manage to get something. You get 36. 36. I check your answer. Do you get 36? You get 36. You get 36? No? Huh? Okay, okay. Speed up. Speed up. 90. And 36 or not? Oh, okay. Okay, 36. Okay, hopefully there's no problem integrating this polynomial. Okay, how about discuss another way to integrate? Okay, let's say we want to do dy dx. Okay, dy dx. So what's my range of x in this case here? And what's the range of y? What's the range of x? For me, finish calculating. I still calculating. Huh? -1 to I. 5. Why? So -1 to 5 just cover this part, right? Okay, -3 to 5. Okay. How about y? How about y? Huh? How about y? Daniel, how about y? Huh? From where to where? X minus x until where? Square root. Square plus 6. This one. Okay. So what's this? What's this here? Okay, I draw this shape for you. What's this? Okay. X is -3 to 5. Okay. And then you start with 1, -1. You start with -1. Okay. And then you cover up to 0. And then above 0, you cover with this this graph here, which is this graph. Okay. So you got some shape like this. Okay. So meaning you are calculating this thing here. Okay, so you cover extra stuff. So how to get rid of this stuff? How to get rid of this stuff? Huh? Minus, of course, minus, but we don't want to do extra work, right? Okay, so we need to pick this bound cleverly. How to pick this bound? Huh? How to pick the bound, the lower bound? Huh, Jinghua? Separating the two part. Why need to separating the two part? I'm just feeling. Okay, this is a gut feeling, intuition. Okay, gut feeling. The other class asked me what's the intuition. Okay. Yeah. So what to do? What to do here? How to find the lower bound? Lingbo, how to find the lower bound? How to find lower bound? So the upper bound is correct already, right? Okay. How to find the lower bound? How to find the lower bound? No idea. No idea. Qingrou, Qingrou, how to find lower bound? Just now Jinghua already give a hint, right? Split. How to split? Why I need to split? X minus 1. So x minus 1 is this line, right? Okay. So x minus 1 is all the way this line. Okay. So let me put this picture back. If you use x minus 1 bound, what do you get? You get this line here. Okay. Right. So you get this line. You still have extra stuff here, right? So how to get rid of this? Separate it and do time 2 times. Okay, what's the other time? Cut from where? What's the point? Okay, cut at the x equals to -1. Okay, and then what happened to the left? Bounded below by yes. Okay, minus square root 2x plus 6. Okay, so you need to split into 2 parts here. Okay, so let me draw it. Or you split into 2 parts at here. Why? Because the top and bottom is bounded by different curve. Okay, bounded by different curve. Okay, so you need to split by 2 parts. Okay, so for x in between -1 and -3 and -1, okay, it is bounded below by minus square root 2x plus 6. And then bounded above by square root 2x plus 6. And then the other case is for x in between -1 and 5, okay? Y is bounded above by square root 2x plus 6 and bounded below by x minus 1. Okay? So this curve here is actually parabola, right? Y square equals to 2x plus 6, okay? You know how to split into these 2 parts here? You know how to split the parabola into 2 square root? You know how to split it? I mean, yeah, similar to the circle example. Okay, similar to not symmetry. So you can see that square root is always positive, right? Okay, so the positive part will represent the positive part of the curve. Then the negative of a positive number is always negative. So negative curve will represent the negative part of the curve. Yeah. Let me think. Always symmetry. Yeah. Because in this case, I think we shift in the x direction. Yeah, we shift in the x direction. Yeah, so the lowest point is at the 0. If I shift out, then not symmetry. Not symmetry across the y equals 0 as. Yeah, the x-axis. Okay.
So the first part. X plus 6, then I just multiply by 2, so they are short person.
Which part? Oh, you mean this part? You mean this part? Okay, so I mean, you need to really be careful. Really make sure this is a symmetry, then you can do this. But in this case here, it is symmetry. Yeah, so you can times 2 of the positive. Yeah, for this case, it is symmetry. Yeah, so instead of integrating from minus square root to positive square root, you can 2 times 0 to square root. Yeah. Okay. Okay. Yeah. Okay. So this integral here split into 2 parts. Okay. So you need to integrate from -3 to -1, and then minus square root 2x plus 6 to square root 2x plus 6 dy dx plus hello. -1, no sound already. Is it? Hello. So integrate from -1 to 5, and then integrate from x minus 1 to square root 2x plus 6. So let me move the integral down. Okay. Let me move. A bit small. Huh? Can see or not? Can you guys see or not? Huh? Yeah. Okay. So let me show you this one. Yeah. So basically, you want to compute this two integral here. Okay. So if you add them up, you should also get 36. Okay. So you can try it. Okay, do you want to try one more example or not? Huh? Can I? Okay. Let's try this example here. Maybe this is easier. Find the volume of the solid that lies under the paraboloid z equals to x squared plus y squared and above the region D in the xy plane, bounded by the line y equals to 2x and the parabola y equals to x squared. Okay. So these curves are easier. So y equals to x squared, y equals to 2x. So where are the intersection point? Where are the intersection point? Huh? So we want to find the intersection point. Section point. Okay. So 2x equals to x squared, which implies x is 0 or 2. Okay. 0 or 2. So when x equals 0, y equals to 0, x equals to 2, y equals to 4. Okay. Okay. So this yeah. Okay, so we got these two intersection here. So what's the choice? You want to do dy dx or dx dy? Pick one. Huh? Dy dx. Okay. Let's do dy dx. So this question asks about volume. Volume. So when does a double integral represent a volume? Qingrao. When does a double integral represent a volume? Oh, positive? Something positive? What's the positive? Yeah, positive volume. No. No, I haven't calculated volume yet. You only got surface. The function has to be always positive. Okay, the function has to be always positive. Must remember, you have to have positive surface. Only then you will get volume if you calculate the double integral. Remember last time we calculate something that cancel out, get 0. Yes, okay. So it must be always positive. So x squared plus y squared is obviously always positive, right? Yes. I mean, within the domain, you need to calculate. Yeah. But this x squared plus y squared is positive always, right? Addition of square number. Okay, square number are positive, then addition of positive number is still positive. Okay, so we want to compute dy dx. So we need to fix x first. So what is x? X is going from where to where? Huh? So look at the graph. Look at the graph. So where's the x ranging? Ranging from 0 to 2. Okay? Okay, check homing again. What is y? What is y? So our x is going from y is 0 to 4. Are you I mean the integration domain. Yeah. Okay. X squared to x. X squared to 2x. Okay, is this correct or not? X squared to 2x. So the bottom one is x squared, the above one is 2x. Okay? Okay. So for every x, okay, you integrate from x squared to 2x, x squared to 2x, x squared to 2x, x squared to 2x, x squared to 2x. Okay, x squared to 2x. Okay? Make sense? Zhe is it Zhe? Yeah. Are you following? Are you following? Or you are blur? Are you following or confused? Haven't wake up. Hello? Okay. So y is integrating from x squared to 2x. Okay. So do this computation here. I give you 2 minutes. Try this integral here. Hey, works again. 真用 here 吗？公真用。OK。梁家园。李杰。李培。李玉章。连夜。刘品义 here， 刘品义 ，OK。刘夏红。玉林。施杰生。OK。子飞。王培武。王熙龙。王宇轩。谢宇轩。许志凯。杨景荣 ，OK。张云。赵静涵。赵以轩。赵以轩。周子康 ，OK。派界。王雅美。申浩伟、苏哲辉、吴承泽。Okay. Have you finished computer? Anyone finish compute? What's this what's this number here? Anyone finish? Peng Yang, did you compute it? What do you get? Okay, good. Yeah, this is the right answer. 116 and over 35. Okay. These are just polynomial integrations, so hopefully you can do it. Okay, 216 over 35. Okay, how about let's say we want to differentiate dy dx dy. Okay, let's say we want to do dx dy. Okay, we want to do dx dy. What's the range of our y and x? Let's ask Zhang Yun. What's our y? What's our y? Our y. 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 Hello. Hello. Okay, Zhang Yun. Hello. Hello. Yeah, Zhang Yun. So what's our y? 0 to 4. Okay, good. So how about our x? 连叶. What's our x? So we fix our y, and then we need to go x direction. So what's our x here? How to find x? Any idea? No idea. Okay. Qiaming, how to find range of x? Bounded below and above by what? Yeah, bounded below by 1 over 2y. Okay, bounded above by what? Square root y. Okay, so how do you get this? Okay, so you should get the bound from this function here. Okay, so on the left, you get x equals to y over 2. Okay, on the right, what do you get? You actually get 2's, right? You actually get x equals to plus minus square root x. Okay, and square root y, sorry. But this part is positive or negative? Positive. Okay, so this line here is actually x equals to square root y. Okay, so this range, this domain here also makes sense. Why? Because we fix y first, and then x is determined by y. Okay. Okay. Okay, so how do you do integration here? So you integrate from 0 to 4 of dy, and then integrate from half y to square root y dx. Okay, so you should check whether this makes sense or not. Okay, this makes sense or not, right? You integrate with respect to x, but the integration domain is depend on y. Why? Because later you need to integrate with respect to y again. Make sense or not? Okay, this match up with the operation we do. Okay, along every y, we integrate with respect to x first, and then in the end, we add up all the y. Okay, add up all the cross section. Yeah. Understand? Okay. Mm, it seems I got one. In my impression, I think got one. Okay, that's all I can answer. Okay. Mm. Yeah, final exam. Yeah. Okay. Okay. So the other I left exercise, then I will provide answer. Okay. Okay, left as exercise. So next, continue. So property of double integral. Okay, so actually we are keep using this already if the two domains don't overlap, we can just do integration domain by domain. Just now we already do this, right? We split the domain into two and then we add them up. Okay, so this is possible. Okay, you are allowed to do this. And then this is a special thing. So if you integrate over the function 1, over the domain, what you get is not volume, it's area. Okay, although the height is 1, but the number you get won't increase. It's just the area times 1. So it's still area. Okay, so this is quite important here. Although you do a 3-dimensional volume, but you still get the area. Area of the domain, yeah, the 2D domain. Okay, so integration, triple integral also the same. If you do triple integral of one function 1, what you get is the volume of your domain. Triple integral, your domain becomes triple 3D. Okay, so, what do you mean? I mean in the triple case. Later we'll see. Okay, in the triple case. Now, double case here, 2-dimensional domain, integrate over 1, you get the area of domain. Number 3 here, if your function is bounded by 2 constants, your integral is also bounded by 2 constants. Is the constant, is the bound multiplied by the area of the domain? Okay, is this obvious or not? This is obvious or not? Because last time we say that the integral respect the inequality. Okay, so you can just stick double integral to all the function. Okay. But just now we say what? Just now we say that if we integrate over the function 1, we get the area of domain. Okay, so we get the area of domain. So meaning we just get m times area of the domain. Okay. Yeah. We just get the area of the domain. Okay. Yeah. Okay. Okay. Do you want to do this? Okay, just quickly, I show you this. So it just says estimate, doesn't ask you to compute. Okay, how to estimate? So they want to show you these property of double integral here. So estimate this integral over what domain? Over a domain of this. Okay, over domain of this. So this domain of this is a this with a center at origin with radius 2. Okay, always you get this question right. The first thing you do is try and draw the domain. Okay, if you don't draw the domain, you are almost failed. Okay, you need to draw a domain. Okay. It's 2. Okay, so how to estimate this? So just now we say that the integral respect the inequalities. Can we get some sort of inequalities out of this function here? Huh? What, Jason? 0 and 2? Function. How to bound our function? How do you know? Function or function? This is domain. Don't confuse. This is domain. Yeah. Our function is e to the sine x cos y. Trigo function, right? Trigo function. How to bound trigo function? Yeah. So sine x cos x bound by -1 to 1. So if you multiply two numbers in -1 to 1, you still get number in -1 to 1. Is that right? Yeah. Multiply any number in between -1 to 1. Do you still get number in -1 to 1? Yeah. Okay. So if you multiply them together, you still get number in between -1 and 1. Okay? Because -1 times -1 become 1, 1 times 1 become 1. And then in between, multiply decimal number, you still get decimal number. Okay? Okay, okay, so we can bound the power, okay, meaning we can bound the exponential function by e to the -1 and e and e. Okay. So by the property 3 just now, how can we bound the, how do we bound this integral in the middle here? Okay, by this property here, it's bounded by the lower constant times the area of the domain and bounded above by the upper constant times the area of the domain. So in this case here, what's the lower bound here? E -1 times, what's the area of the domain here? 4 pi. Okay, good. What's the formula? Pi r squared. Okay, so here area is pi r squared. Okay. Correct. Area of the circle, pi r squared. So area of circle is this. So bounded above by e times 4 pi. Okay. Yeah, circle formula is pi r squared. So radius is 2, so pi 2 squared is 4 pi. Okay. Daniel can follow now. Huh? Sorry? Can follow? Okay, okay. Yeah, okay. So there's not much enlightening here. Just show you some property. Okay, next one is a key important stuff. Okay, polar coordinates. Okay, so instead of integrate over rectangular coordinate, sometimes we want to integrate over polar coordinate. Okay, so in polar coordinate we have this polar rectangle. Okay, if we are using r and theta, if we fix r and theta, then we'll get this rectangle instead of the normal rectangle. Okay, so this is a result of bounding r, okay, and theta. Okay. So previously we bound x and y. Okay, so that's why we call the first one rectangular coordinate, and then we call the second one polar coordinate. Okay, because the first one usually you get rectangle, the other one you get some sector. Okay, you get some sector. Okay, I don't want to explain how we do find this area here, but if we change coordinate from rectangular to polar coordinates, okay, what you do is you replace your xy with r cos theta and r sin theta. Okay, so this one should remind you the chapter, what's the chapter? Chapter 10. Okay, chapter 10. Okay, should remind you of chapter 10. But the extra thing here is this r. You need to multiply this extra r here. Okay, why? You can see that this area here, right? These two areas have some difference. Okay, these two areas have some difference. Okay, so this difference here is captured by this extra r function. Okay, so you need to always remember when you want to integrate over polar coordinate, you need to add this extra r function in. Okay, I'll show you example. Okay, show you example. Okay, this question here. So evaluate this function as a region in the upper half plane bounded by circles x squared plus y squared equals to 1 and x squared plus y squared equals to 4. Okay, so let's draw this circle up. Okay, first thing you saw this question, right? Draw the domain. Okay, draw the domain. So what are the two circles you want? A unique circle and a circle with radius 4. Unique circle and circle with radius 4. So where's the R region? Huh? Radius 2. Sorry, radius 2. Yeah, radius 2. So this is radius 1. The other one is radius 2. Correct. So you need to take the square root. Okay, take the square root. Alright. Okay. So I mean, this is 2 square. This is 1 square. Okay. S square plus Y square equals to R square. Okay. Yeah, you should think of it as a Pythagoras theorem. S square plus B square equals C square. Okay, good. Okay, so this is a radius 2 and a radius 1 circle. So where's the R here? R is the region in the upper half plane bounded by these two circles. So where's R? Where's R? Yeah. No, this region R, sorry. Region R. Yeah. So where is it? So it's the stripe. Okay, so it's the half donut, sure. Half donut here. And this is a flat donut. Okay, so it's this part here. Okay. So you want to do dx dy or dy dx? Can you do dy dx or dx dy or not? Huh? Dx dy. Okay. So let's see what happens if we do dx dy. Dy dx. Dy dx. Okay, dy dx. So we fix x first and then we fix y. So x is going from where to where? So what are these points? -2 and 2. Right? Okay, so we go from -2 to 2. How about y? How to control y? How to control y? So your y is controlled by this thing, right? Bounded below by this, and then bounded above by the upper curve. Okay, so let's give this curve some name. So this curve is square root 4 minus x squared, right? Correct or not? Okay. About the inner one, this curve is square root 1 minus x squared. Okay, this is y. Okay. How about these two lines here? This is y equals 0. The other one is y equals 0. Okay. So what happened is you need to cut into 3 parts. Okay, you do this. Okay, you need to cut into 3 parts. Okay, because this part here is bounded above by this curve, bounded below by this curve. And then the middle part is bounded below by smaller circle, bounded above by larger circle. And the other part you got the same. But oh, you mean this one times 2? Okay. Oh, yeah, I forgot. Sorry, I forgot this now. Okay, you see, although this is the question I answered Rennie's 2 days ago. So although you see that this domain is symmetric, right? Okay, but you need to check that whether your function is symmetric or not. Because what you calculate is the volume under this surface. Okay, so you cannot simply times 2. Unless this function here is symmetric across these two parts. Then you can. Yeah. Function also, not just domain need to symmetric. Because if it is symmetric but your function is not symmetric, then you cannot multiply. Okay, unless it is symmetric on the function also, then you can split it. Okay, so don't simply split your integral. Okay, so now you need to split into three parts here. Okay, so how? Okay, so how? So actually, there's a way to do this. Okay, there's a way to do this using the polar coordinate. polar coordinate can treat this whole domain as one. Okay, so how to use polar coordinate here? Okay, you realize that this is actually a polar rectangle. Okay, you just need to control your radius, control your angle, then you can draw this R out. Can you imagine how to draw this one? Cannot imagine? Ah, yes, draw this R. Let me write first. So, okay, 3x. So my strategy now is I want to turn this into dr d theta. Okay, so to do this, I need to introduce an extra r here. Okay, remember this extra r. Later we will say how this r comes from. This is something called Jacobian. Okay, Jacobian, yeah. So there's an extra r when you go to polar coordinate and then multiply with the function. So this function is what? You need to substitute x as r cos theta plus 4r sine theta squared. Okay, so what's your integration domain here? Okay, I claim that this is a polar rectangle. Do you know how to make this rectangle? What's the angle and what's the radius you need? Okay, radius is from 0 to pi. Remember the theta is going from positive x-axis. Okay, let's say we already cover 0 to pi here. What else do we need to form this rectangle? Now we have this part already, 0 to 2 pi. At 0 to pi. Okay, so how do we form this middle part? So what happened? What happened to the radius? Radius is going from where to where? Yes. Okay, so the radius is going from 1 to 2 because if I start with radius 1, it is this line. End with radius 2, it is this line. And then we take everything in between 0 and 2 pi. So we form this radius here. Okay, so one thing you need to recognize is this is a polar rectangle. You can use 4 number in the polar coordinate to build this rectangle. Okay. Yeah. Okay. So how to see polar rectangle is like a sector of your circle. One of them is sector of the circle, and then the other is is this donut-like shape. Can you see that this rectangle here is an extension of this rectangle? So you increase the radius. Make sense or not? Okay. So how about decrease the radius? What happened? You will get this whole thing. Okay. If you increase more here, then you get a pizza, something like that. Okay, and then you can increase. Yeah. Okay, so you can get pizza and then you can get donut in polar coordinate. Okay, can we integrate this now? After integrate this, we'll take a break. So let's compute this. What's this? Pizza. You need to move hand one. Huh? Yeah, pen. Okay, see what's the final answer. Anyone got final answer yet? Ah, 15 pi over 2? This one. 15 pi over 2. You say you don't have 10, but you got the answer. Hey, you cheating, eh? Cheating. Anyone finish compute? Finish compute? Until finish No? Yi Hui got do not yet. 先开单的。Sri Lanka got it. Got it. 15 pi over 2. Everyone got 15 pi over 2? Fifteen pi over 2, everyone got it? Got it? Okay. Yeah. So I will like attach two regular coordinate method, and then you can see how tedious is it compared to this one. Okay. Yeah. Yeah, I will attach this. Yeah, if you use coordinate, then you need to deal with this thing. You also get 15 pi over 2. But the last step here is a bit troublesome. Okay. Yeah, so if you use regular coordinate, then you will meet this. When you use polar coordinate. When do you use polar coordinate? When your domain can be expressed in polar rectangle. Okay, meaning using radius and angle, you can draw the domain. Then you can use polar coordinate. Actually, the main part is the domain. Domain. You see, because this domain, if you use regular, you need to split so many things out. Remember just now we discussed, right? So if you use polar, then we can do it one go. Correct or not? Okay. So you need to differentiate. Okay. So I think if you meet circle, then you can straight away use polar. Circle, right? Okay. You just use constant. Okay. You just use constant to integrate. Okay. Let's take a break until 917. Okay. Yeah. Yeah.
这里 sin x 和 sin x 它是大于负一，它是负一到一啊，不应该是1/2到1/2。是的呀，这个的它的 range 就是在负1/2到1/2啊，就是 -1/2 1/2。然后我还验证了，我还用图像验证了。
哦，我知道，阿明，OK，可能我们的没有那么准确。
是啊，这样子说的话，那我可以取 negative 这个，那我可以
当然，但是他只是说一个 estimate 哦，所以我们
对，我想问这个题就是
这样只是
estimate 不就是刚好你这个人的这个这样子吗？而不是这样子 estimate，那你可以用整个教室来 estimate my wife 的这种感觉。对啊，
你可以这样说，但是怎么说呢？也属于正常，没有到很准，但是还正常。
所以说考试的时候
你不可以说哪个
negative
infinity 到 infinity 这样就不太好嘛，对不对？
那我取一个很明显的10000到负10000，你也不能看我错啊！如果这样子，
这样子实际上可能真的也是没有错的。
但是我觉得
但是你这个，1/2到1/2好像要特别正的吧？
我不知道，我当时
对，要特
用的时候，
别正。
我一看不就是取那个square 取那个 √2/2那里那个点吗？就刚好是它的 max 的 point，就是
哦，你要找它的 max point。
不是，我只是想找这个。因为你如果从这个推到这里的话，其实不准确了，因为这个 sin x cosine y 它的 range 就是我知道你的意思，它是说 range limit 在这个 -1 和1之间，但实际上它的 range 在缩小化的话，确切的来说，
我知道是在缩小化，但是问题是你要证明哦，你要证明。
就是
你不是
在那个
用
pi
除
over
哦，它的为什么会被缩到1/2？是因为刚刚好他们遇到的时候
对啊，就是
啊。但是你既然单从这两个，你怎样知道它什么时候遇到？你懂我意思？
对你说对，然后所以我讲 Pola 的那个时候，我在想怎么去证明那个点的时候，他们的那个是刚好最大的，就是如何他们在交点的时候，就是我很
哪一个？
就是
说前面呢？
没有，就刚刚
这个
就是我在你讲那个 Pola 的时候，我一直在想这道题，我在想就是
没有
如何证明是在那个 pi over 4的时候刚好是那个它的那个
我没有证明啊，我也不需要用它。
我在想
OK，
我觉得这样就很
所以很难啊，
可以用筹天道的方式筹出来。
是的，可以求导啊。
对，
但是这样子的话就很不准确啊。
你可以这样说，你可以这样。
我就觉得这道题就是它负一跟一应该是取不到的，我觉得。
什么？
没有，是取不到的。老师的意思是说，它是负1/2到2/2，对不对？但是老师说就是随便了，就是
包在
对，包在负1到1。
如果考试考到就直接取正负一，什么这种就是
行嘞，老师不行嘞。考试的时候这样子的话，那不很随便吗？
这样是不是
不行嘞？
说遇到这种3角函数直接取正负一，是不是一种典型做法？
对，典型
遇到这种估计题。
对啊，因为目前遇到 sin cosine 的都是取的正负一的 range 啊。很不科学啊！这不是数学，这不是数学。
但如果说你如果说去证明它那个取值范围，那这道题的工作量太大，那它
对，我觉得
负的分子
你要做很多，
那你的负的分子就相应变大，那是不科学的，在一个考试。
好了，你好聪明啊，好聪明！
你相当于做一道题，你做2道题。
有的嘞。
所以这种估计的题的话，就不能确切的做，就是只能用估计的方法去做。 哦，所以像这样求的话，就是不应该是这么求是吧？
这个就不是求了，这个就直接算出来了，这不是 estimate 啊，这直接 compute，
这是 estimate，
这就 compute 啊，直接。
是它这个积分应该积不出来了吧？这个
可以积吧，可以吧，因为可是到最后你又有这么混合的东西在里面，应该到第2步比较难，第1步应该比较难。
这个我还积得出来，
我还没试呢，然后就发现。
我觉得如果积得出来的话，他不会拿来作为不算了，我觉得，因为这种
可以这样讲，你可以这样讲，但是我觉得是积得出来，应该积得出来。
只要你的脑力够，
然后你够
有些时候
恒心够，
你碰到这种什么e 的几次，
恒心够就可以了。
那软件都积不出来，有些时候e 的什么3x 次这种，
没有是1配合到什么 ？OK， 等一下我会给你们看一个东西。OK， 我看一个东西。
还有这个就是这个不能 split 吧，是吧？因为它不是 rectangle。
喂，你在讲什么 split？ 因为为什么不能 split？ 是因为你是说 split integral 哈？
对，
因为你看这个是 depend on y。
对，因为它是个常数。
对。
上面 rectangle 它是有确切的常数的，它可以。
对，
没有错。
Yeah。现在不能解释，等下再解释。
因为我
做方面的事。OK， 我刚才解释的方法是，因为你看这2个 rectangle 有差别，那个 r 会补足这个差别。对。我会 prove 这个东西从哪里来罢了，然后我也不会跟你讲这个东西到底为什么要加进去。但是问题是要解释这个东西怎样加进去，就是要解释它这个 rectangle 怎么变。你要看到的东西就是这2个 rectangle 有差别。OK， 这 rectangle 越变越小，这 rectangle 也是会越变越小，但是越变越小的时候，你看它的形状跟它形状一定是不一样。但是你要知道它这个越变越小，其实它就是在 estimate 这个 rectangle。对。没有， 这个东西是它，你这个是这个 r 跟 θ 是给出这个 rectangle， 然后你现在我是说这一个 part 啊，你每次我们不是写 dA 吗？它是这个 area， 它是这个 area， 所以你看一下这个两个形状是不是有点不一样？所以它 area 应该有一点不同，然后这个不同的点被这个 r capture。
那因为我们都没是在用 F， 所以我们不能直接也是用 R 跟 θ 代替。
可以，那些东西都没有问题。问题的是这个 rectangle， 这个 polar rectangle 出来的 area 跟这个 rectangular 的 rectangle 算出来的 area， 这两个 area 有差。
是我们在说
因为我们是要在这个世界算的东西，我们放来这边算，对吧？你看这个 dA 是活在 rectangular， 这边是活在 polar， 这两个都是活在 xy plane。这个，对，
讲那个 R 怎么是你讲个 R 的？你拿这边的 domain 嘛 ，right？
对。
它会有多余的东西，用 R 来算。
它会有多余的东西。它会有多余的东西。
记得你讲啊。
我不是很想讲。你想听啊？它是要取 limit 啊，不然我先跟你讲讲看，你觉得合不合理？要不要讲？给你看了。
做那个时候，想那个道理。
想那个道理，就是那个 area 会变，你还是不明白为什么 area 会变，是不是？你看，它原本是这个圈圈，它现在变成这个圈圈，这个圈圈哦，它这个线啊不直了哦，不直啊 ，in general 不直啦，虽然你在这边看是直 ，in general 不直，所以你 reduce 一下啊，它会跑出这个part 出来。但你要算，你看，你只能够算直的 rectangle，OK， 你只能够算直的 rectangle， 但是你 in general 是这样弯弯的，所以这个直的怎样去算这个弯的东西，它会跑出这个 cross product 来，这个 cross product 就是这个 r 算出来的这个 r 的这个情况。等下我会跟你讲，之后我会告诉你这个 r 怎样来，但是我不会可能讲这些东西了。就是说那个，或者你可以想说是那个弯弯的，我要把它拉直来算，懂这意思？就是 OK， 就是我要这一个 rectangle 去算我这个变形过后的 rectangle， 就是比如说这个情况，我变形到这个 rectangle，OK， 然后OK， 所以你这个 rectangle 你要想成是一个变形的 rectangle， 所以我要把它变回来才可以算，变回来的单额呢，增加了这个 r。这样子讲，可以吗？这个是一个变形的 rectangle，and then 如果我要把它算回来，因为我只会算这样子四次方方嘛，所以我把它调回来的时候就多了这个 r 的东西。
可以用 like y 跟 x 直接算一点，就是说它变 r 跟 θ 的时候，就还要变来变去。
变来变去。
但是我不要看这个，我要上这个吧。
y
跟 x 可以是对啊，对。
OK。
再加了一个 r 这种。
对。
r 跟 θ 还要加那个 r， 你也不是算那个圆圈。这个 OK， 我要明白这个，可以用这个来算。可是算那些圆圈 ，x 跟 y 也可以算圆圈啊，它不是算正常形状，对。算圆圈，你要把它变成。
因为我的点，你看我的点，我不是用 xy 的点了，我是用 r θ 的点。你看0拍1 2，这是 polar 的点，不是 xy 点。xy 点什么 ？xy 点是减20 20 02，然后0减2，不是这些拍。
你的 point 是不大一样是
polar 点 polar coordinate 用 polar coordinate 来形容这个点。对。Hello。 Hello, should we start? Come back. Let's come back.
妹妹交不完不要紧 ，OK，exam 出我放你。
Yeah. 会的。对，一定。
这是哦，那个你不要讲考的话，你讲不会考的话。
I mean the quiz, the coming quiz, right, is I think almost the exam question. So if we can do the quiz, then you should be able. I mean, should be almost the same. The final. Exactly cannot. Maybe week 14. Not sure yet. Yeah, formula sheet will give. Later I will share the formula sheet as well. Hopefully it's useful. Okay, do we let this for exercise and do one fun thing or? Okay. So let's do an exercise homework. Okay, do one interesting stuff. Okay, anyone remember this meme or not? Remember this meme? Okay, have you guys in the integral in the probability class see Gaussian equation? Yeah, so this. Have you seen this is equal to square root pi? In probability class, got use this or not? No way? No one? Yes? Gaussian integral, no. Don't have this probability class. No. Okay. So no, it's square root pi. So let's compute this. Okay. So compute this phase. Okay, compute this phase here. Okay, now next time if people show you this, right, you should know how to compute this. Okay. No. Use polar coordinate. Okay, use polar coordinate. So let's compute this. Okay. So let this equal to the integral. Okay, that we want to compute. Okay, how we use polar coordinate. So here we only have real line R. So how to make out R2? How to make out two-dimensional R? How to make out two-dimensional R? How to make out? From 1R, how to get 2R? Times R. Okay, put two together. Okay, so we consider two of them together. We consider I squared. Okay. Okay, we consider two of them double copy. Okay. Yeah. So here, what is this? This is a double integral. Okay. So double integral. Okay, so this is the double integral. So you need to integrate from infinity to infinity. Wow, how to do this? Okay, so just now I said we want to turn this into a polar coordinate. Okay, how to turn it into polar coordinate here? R dr d theta. Okay, but what happened to this function here? S squared plus y squared satisfy what equation? R squared. Okay, very good. So minus R squared. Okay. 1 because but x equals to r cos theta, right? So you still have a r squared cos squared plus. Yeah, so let me write down here. X equal to r cos theta, y equals to r sin theta. So x squared plus y squared equals to r squared. How about the integration domain become? So what happened to the angle? So you need to integrate the whole R2, right? So how you cover the whole R2 using polar coordinate? You need to consider all the angle 0 to 2 pi and then radius from where to where? 0 to infinity, right? Need to cover everything. What? We want to cover the whole R2. So you need to take all the angle and then all the radius. All right. Okay. So now good. Okay, we got this. So there's no theta, right? So we can split out the theta. Okay, we split out the theta. And then how about this? RE minus R squared dr. Huh? So we go to the happy phase now. Right? RE to the minus R squared. Okay, so we go from the sad phase, go to a happy phase. Okay, so we know how to integrate this. So how to integrate that one? What you do? You do substitution by subs. So you do the integration by substitution. Okay, integration by substitution. What to do? Z equals to R squared. Dz equals to 2R dr, and then you can sub it in. So what do you get? Infinity squared. So maybe we make it into improper first. Okay, so become a squared 0 e to the minus z divided by 2 dz. Okay, why is it a squared? Because I use the chain of variable. So if you like, I can do this first. Okay, and then I make a chain of variable z equals to r squared. So a become a squared. Okay, can or not? Change of variable from here. A got r. Okay, so first of all, I change the this improper integral into definite integral, limit of definite integral, and then I use integration by substitution. So I change the two limit here, right? When r equals to a, z equals to a squared. When r equals to 0, z equals to 0. Okay? Integration by substitution. A is an improper integral. No. I'm just introducing this improper integral here. So this is the limit of my improper integral. A squared, because I change integration by substitution, right? You need to change your integration domain based on your substitution. Okay. Okay. So in the end, what do you get from this integral here? Minus e to the minus z of 0 to x squared. What do you get? Huh? What's this part? What's this part here? Not 0, eh? So the first term is 0 because you take infinity, but the second term plus 1 over e to the power 0, so it's 1. Okay? So you get pi. Okay, so in the end, you get I square equals to pi, which is implied I equals to square root 5. Okay? Why not plus minus? What's this graph here? This graph is positive or negative? Always positive. Okay, so you won't get negative area. Okay, so positive. Okay. Okay or not? How you think about how to go from I to I square, is it? No. I mean, how to go from I to I square, because you need to know the technology in I square first. So R2 first, then you can use something there. We also can make it into R3 also can. Yeah, later we will learn spherical coordinate. So later you also can do it there. Yeah. Okay. So I mean, in principle, everything you can do it. You can up a dimension and then calculate it. Depend whether it is easier or harder. Yeah. Everything you can do this. Yeah. Okay. Yeah. Okay. 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 So this is a useful thing of this. Okay. Let's go on first. So integration in polar coordinate over general region. So in polar coordinate, we also can have irregular rectangle. Okay. The side of the rectangle controlled by your angle or controlled by your radius. Both can. Okay. Yeah. This is similar to the XY. So Y is controlled by X or X is controlled by Y. So this is similar case. Okay. So let's do some example here. This example. So I use a double integral to find the area enclosed by a loop of 4 leaf. Loop of 4 leaf. Okay. You want to find area. So how to find area? How to use double integral to find area just now? You need to integrate over the function. What function you do integrate over? What's the function you need to integrate over? 1. Okay, so integrate over 1. So in this case here, what's the domain? What's the shaded region here? How do you? So in this case here, how do you describe this in polar? You need to use radius and angle. Okay, what's the radius and what's the angle here? Radius, radius, you mean radius? Angle. Okay, angle is negative pi over 4 to pi over 4. Okay, how about radius? So how you get this radius? Okay, sure. So your radius for this loop here is bounded below by what? Bounded above by what? Bounded below by? Bounded below by what? The radius? 0. Okay, bounded above by what? 1. 1. Okay, what's this shape here? Again, okay, this is what's this shape? So you have minus pi over 4 to pi over 4. And then the radius is everything from 0 to 1. Oh, 0 to 1, right? From 0 to 1. So this is the domain you want to integrate over. Okay, so how? Yeah, what do you mean change your okay. Yeah, so need to change this change to this boundary. How to change? How to control this? Cos 2 theta, right? This boundary here is just cos 2 theta, because this graph is what? This graph is r equals to cos 2 theta. So when you trace through the angle, it's exactly this graph here. Okay, so you integrate from 0 to this point, to this point, to this point. So the cross section here, see? So chapter 10 come in now. So the cross section here is this. Okay, 0 to the radius, 0 to the radius. Okay, along the angle. So your angle now is this ray. Okay, you should think of it as a light ray going to the origin. Okay. 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 Question. Leon got question or not? Still confused. Okay. Okay. So in other words, our integral is going from minus pi over 4 for the angle. Okay, and then for radius going from 0 to cos 2 pi. 2 pi dr. Okay, is it enough? Enough or not? This integral. Still got a r. Okay, when you change polar coordinate, you must have a extra r. Okay, later we'll call this a Jacobian. Okay, so compute this. Okay, compute this. Get Okay, let's see what you get. The end. Huh? Hey, what's going on? Okay, what do you get? Pi over 8. Yeah, good. Yeah, pi over 8. Okay, good. Okay, next one. Okay, next this one. Huh? Actually. Hey, whoever just come, need to tell me, because just now I got attendance just now. If I didn't call your name, you should. Who the one? Li Yuzhang. Yeah, Li Yuzhang. Okay. Yeah. I call inside my mind. Okay. Huh? Okay. Okay. Find the volume of the solid under the surface Z equals to x squared plus y squared above xy plane, and inside the cylinder x squared plus y squared equals to 2x. Okay. Anyone recognize this is actually a cylinder? There's only XY variable, but why is it a cylinder? Yeah, because yeah, this is a circle. Yeah, what's the center here? What's the center? Okay. Discuss what's the center here. No, 0, 0. Because there's an extra 2x here. So become actually is 1, 0. 1, 0. You need to completing the square. Can everyone see or not? Need to completing the square. So x squared minus 2x plus y squared equals 0. Okay. And then you need to write it in x minus 1 squared plus y squared, which equals to 1. Okay, completing the square. Okay. And then there's no z here, right? So you need to consider the circle in every z direction. So you form a cylinder. Okay. So you see your domain is like round. Okay, it's round. So the first thing you should think of is polar coordinates. Okay, it's a polar rectangle. So I already write down this polar rectangle already. This is your exam question, right? I equals to 2 cos theta. I mean similar. Okay, write it in a polar form. Okay, what's the range for this rectangle? Anyone still remember or not? This is the first few example we see. What's the radius? What's the angle? Radius going from where to where? 0 to 2 cos theta. Okay. How about angle? 0 to pi. Okay, make sure. Remember, this is the special Limason last time. Only with just with 0 to pi, we can draw the whole circle. No need go to 2 pi. If you go to 2 pi, then you will repeat again. Okay. Remember this example last time we draw only from 0 to 2 pi, we can finish the whole line. Whole circle. Okay. Very good. Hey, you guys are more attentive than the math student.
Yeah, that's why you go. Why you keep talking to MSD student?
Need to help them. They are weak.
No.
I mean, yeah.
这个顶是我 presentation 的时候跟他们讲的一次吧。哎，有 recording 啊，有 recording 啊。
I mean, they are really weak. I know. I mean, they don't prepare their lecture notes when they come to class.
They don't need.
They don't need what?
They don't need.
But they also don't know. When you ask them, they don't know. They blur one. Yeah. Yeah. Right. Maybe they can do last minute study, but on the spot also cannot. Okay. So what's the domain change here? What's the dr d theta here? Okay. R is going from 0 to 2 cos theta. Theta R is going from 0 to pi. Okay. So what happened to our function here? R squared plus y squared become what? Become R squared. Okay, good. Because this is the change of variable. Yeah, become R cube. So you need to differentiate R cube. Okay. Do we? Okay. So at the end, you should get 3 pi over 2. Okay, at the end, you should get 3 pi over 2. Okay, you should get 3 pi over 2. Okay, you can calculate and I show you something I do during my not free time, but I don't want to say it's my free time, but so let me see. So you see, I do it in a rectangular coordinate. You see rectangular coordinate. See how complicated it can get. Okay. So I compute the what is this? This is dy dx. Okay. So I split into positive and negative hemisphere here. Okay. And then you will reach this weird not weird, but complicated square root function here. So you need to play the angle stuff here, angle substitution, so that the pi will drop out. The tangent theta something, the trick. Yeah. The tangent trick or what. And then how about the other one? If I do dx dy, okay, and I need to split further. Okay, I need to split further. And then you also will reach this square root function thingy. So you need to use. I use computer answer. Yeah. Okay. Cannot. Okay. Yeah. So you can see how complicated it can get. Okay, if you use dx dy. Okay, but if you use polar, you just integrate over r cube. That's all. Okay, you just integrate over r cube, and then the radius and the theta controlled by easier constant. Okay. I forgot. Okay, let me next time I read closely the question and then I tell you. Now, wait. Don't do that, huh? Huh? What?
Remember to off your computer. To off the projector when you check the question.
Okay. Next time. Okay. Next. Okay. So this application, right? Just ignore it. Okay. This one not examinable. Huh? 就是什么？真的没有。Yeah, no nothing. Unless the exam unit print wrong. This one need to talk a little bit. Huh? 46. Oh. Okay. Okay. This surface area. We come back next week. But I want to talk about this box first. Okay. I want to talk about triple integral first. Okay. Maybe we don't do exercise, but we talk about the idea first.
You also don't.
Huh?
You don't
Which area? This one we will do next time. Surface area we will do next time. But we do box first. We do box first, huh? Okay. So we introduce box first, and then next time we'll come back to this area thing. Okay. Okay, triple integral. Okay, so what happened to triple integral here? So just now we only have domain in R2, but now we have domain in R3. Okay, in R3, you need to consider cuboid. Okay, there are 3 sides here. Before we only have 2 directions, X and Y, you need to cut. Now you need to cut Z direction also. Okay. So the triple integral is a limit, triple limit, and triple sum. Triply limit and triply sum. Okay. So what's this integral are you calculating here? You got R3 plus function R. So what's this R4? You cannot imagine already. Okay, the textbook call it a hypervolume. Okay, so remember this is just a domain picture. This is the picture in domain. Okay, the picture in domain. Okay, so in this case, we also have similar stuff to Fubini's theorem. Okay, so if you are continuous, okay, on the rectangular domain, you also can solve your integral, no matter how you structure. So how many possible ways you can solve it? 3 factorial. 3 factorial. 6, yeah, 3 factorial. 3 times 2, 6. Okay, there are 6 ways. 3 factorial. Okay. So in this case, for example, this example here, you got a box. Okay, you got a box. X controlled by 0 to 1. Okay. X is controlled by 0 to 1. Okay. Y is controlled by -1 to 2. Okay, and then Z is controlled by 0 to 0 to 3. Okay, so this is a box. Okay, this is just a domain, this is B. So this is domain B. Okay, domain B. But this is R X Y Z squared. Wow. 踩点 huh? This is not running Okay, next time need at least 15 minutes before. Okay. Okay, so this function is xyz squared. Okay, xyz squared. Okay, so any order you can pick. Okay, any order you can pick. Okay, so what kind of order you can pick? You can pick, for example, dx, dy, dz. Okay, so in this case here, z is going from 0 to 3, y is going from minus 1 to 2, x is going from 0 to 1. Okay. Okay. So can you see that this is an easy integral or not? X, Y, Z, you can just split to 3 integral. Okay, just split into 3 integral and then you compute. Okay, and then I want to roughly go through the idea first. Next time we'll do example. So we also have general region. So not always you will get rectangular one. Okay, you don't always get rectangular. Okay, you will get other rectangle. So for example, this domain here, okay, this domain E here, the top and bottom can be controlled by X and Y. Okay, controlled by X and Y. Okay, and then further, you also can further control your Y or X variable. Okay, let's say your X is bounded by 2 constants, and then your Y change depend on X. And then your Z change depend on your X and Y. Okay, yeah. Okay. But the idea here is you need to know how to arrange your dx, dy, dz in this case. Okay, you need to know how to arrange them. Okay, so the most dependent variable you need to keep inside. Okay, the most dependent variable you need to keep inside, and then slowly reduce. Okay, so for example here, okay, go through this last example here, and then we will finish. So you can see here, z is dependent on x and y. Okay, so you need to keep dz before y and z. Okay, and then y is dependent on x. So you need to do y first before you do x. Okay, do you get what I say? Do you get what I said? Okay. 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 So next week we will do example again. We will see example. Okay. See you next week. Huh? Yes. Yes. That's right. 你是谁？宋子飞。宋子飞。宋子飞。OK。OK。对，没有错。